They're separated by a space of air that's even, and the strength of the insulating material between the two is what affects your capacitance. So normally they're full crude oil, they'll have a capacitance. If you start adding water or sediment to it, it'll change what's called the dielectric constant, or the strength of the insulating material. And that's really all you're measuring. Every probe from the factory is 75 picofarrads. Whether it's this size, a 2-inch, or that big 645 model there. So that's one thing that's good to know. Like right out of the factory, it's 75 picofarrads. In a vacuum, it's standard conditions. But right out of the box, they're usually about 85. So 85 to 90, just in the air. One check I like to do is you can
move it side to side.
We'll rebuild this, and then we'll leave it out in the air, and we'll see the capacitance value, and then you can fill it with I have like number 2 diesel fuel, and that always reads like 178, and it's pretty reliable. So I always use that as a reference, like, hey, is this probe any good? Am I getting a good number? And so that's a good thing, a good check. So, get that out of the way. So with that being said, all we're doing on the inside of the probe, do they want to part? Well, we'll get to that, but the part where that probe clips on inside, you probably all had to get in there and clip this little probe, that little probe wire. Yep. That's all that is that's a direct electrical connection through the seal to this inner electrode. Then the outer one is ground. So basically, this is a test replacement for this whole setup.
All right.
So what I'm going to do is just clip on to here, and that's going to go where the probe wire goes, and then this goes to ground. This is a convenient ground. The screws are so. And you've probably seen if that head's loose or all your grounds aren't tight, your numbers will jump around, because you're measuring picofarads, which you can see if you put these together, you can just put a piece of paper or your finger even nearby, and it starts to jump around. So it's real sensitive. So let's let the smoke out of this guy.
Heck yeah.
Like these new ones, they get kind of funny, so I always stick that in there to bend that little tab out a little bit. Another thing I'd recommend, if you set up a little test area to work on these, I'd recommend putting like a little milliamp meter in series with your test voltage. Because you'll start to notice, like, okay, every board that's good right out of the box always draws, I don't know, 180 milliamps. Well, then also you get one to feel it's not working, you hook it up and you see it go up, something way off of that, something's different, something's wrong.
Inside the board.
They'll save you a lot of time. Okay. So you're saying this is a good one?
Yep. Well,
it said good.
Was.
The baggie says good.
Hey.
See, it's saying check probe wire, which is the same. So it knows, like, it'll see so much capacitance, and if it's seeing close to 75, 90-ish, it knows, okay, well, obviously the probe must be there, but it might just be empty. That's why you'll see like low decay empty pipe. The low decay means low dielectric constant, low insulating strength. This one here, it's way off, so it's saying check probe wire, because it's like, I don't even see that. So we'll hook up the probe.
Then it should go away. Low calcium.
Now, like with these test boxes, like just putting my hands on the ground, I can actually change the values, but it's below Cal 0. So a lot of times, you know, in the field, they didn't calibrate it right. They thought their water cut was one thing and they entered the wrong number. So a quick test is we
Yeah,
can try to
happens a lot.
calibrate it. This box here is like
Set it
167
to
to,
0.05.
yeah, and all that's in there, when I flip the switch there, it's 167 picofarad capacitor, or here it's like 188. So let's try to calibrate it. Everybody knows how to do this?
Yeah.
Okay.
How to do that like on hard time.
Yeah.
What are you doing?
Oh.
Yeah.
One cut, and we'll call it 0.05. Now every oil is going to be different. You know, you could have a different gravity oil from a different supply, and your grind out might be 0.05, but it might be off of this. It's all comparative, meaning this thing looks at what you're sending at that time, and that's all it can do is start from there. So you could have several different capacitances. If I calibrate it for this, it's assuming one temperature, one gravity, and then the capacitance with that oil. But you could have another API gravity or different water cut and get similar values because everything's going to affect that. So the important thing to remember is it takes a snapshot of this product at these conditions and what you're telling it from your grind out, so you know what it is. So I'm going to tell it a 0.05.
You can put that at
Manual TC,
zero
we set to
sometimes.
0 if you don't want to use it,
Yeah.
or 600 is the default.
get rid of that
So
alarm.
let's put it for 0 right now. And 20 milliamps, I'll set it to 5 because that's what this is. Set point, that's just where the relay clicks. That's how long it takes for
Kill it.
to be bad before the relay comes on.
Do you use the DK alarm for anything?
You can. What that'll do is that ramps the output up high, right? If you have low decay.
Okay. Because I've seen that alarm a lot, but it doesn't.
It'll make an alarm, and on the newer ones, it makes like a high failsafe. Like it'll make the value go high, so your automation sees it as like a high water cut and knows to divert. So now this box can give you anywhere from like 4.5, 4 to 5, depending on how the unit's been calibrated. But it's ballpark.
Yeah. You can tell it's close enough.
So, hold on one second. I should turn my phone off. Hold on one second. This is Brian. I gotta take. Hey, Brian.
Brian's important.
Yeah. Sorry, guys. 1 minute.
No worries.
So it should
4.12.
shut off in that time period he entered, right? What do we usually enter?
For what?
Sometimes the Bs&W kills it quick once it's off, like 30
Yes, sir.
seconds.
Yeah,
You put
they're
in
all
whatever
different.
grind out is. This is just to bring the board back to
The
factory spec.
Picofarrins.
I mean, like the time, like the delay, so if it reads
Typically
bad
30
oil.
seconds or a
Okay.
minute.
And you could set that in there, right?
Yeah.
Yeah, 167 is 0.05 in ideal oil. It's a factor that's about the bottom of most oils. But like he was saying, your oils, if you have an oil that's got different, if it's got chemicals in it, a little more Bs&W in it or whatever, if you get a grind out that's 0.05,
Condensate is
then
That'll really put it high.
26.9 Fahrenheit. Okay, see that 194.3?
Yeah, what's that?
So
Oh, is that the Farads?
I'm shooting at 188. Okay, so let's go over here. So 174, we're within 5.
How'd you get to that?
You switch the.
I switched the box.
I mean, how'd you get to the Picofarrins?
Oh,
You
Isn't
hit
it
the
the
up and down
m-
arrow, and it'll scroll through
Yeah.
temperature.
Yeah, the up
cut.
arrow.
There's your cut 0. Your temp. And there's your.
So the value here and value here was
The lower value is what it's actually seeing. See? So if
the
I
lower
take this
value
off,
here.
now it's just freaking out. Check probe
yeah.
water.
So if the lower value here is 164,
174, yeah. Now, so here's the other thing you can see how my 0 is today. Yeah, we're gonna have to.
Now, does this send the signal to the flow computer to turn it off,
PLC.
or the PLC?
Yeah.
Because I've seen this value from this be different than on the HMI. Like when you go to lax skid and you can see the whole thing. Like they'll be different, like by a little, not a lot.
Well,
And I
a
wonder if
delay
that's just
too.
resistance.
So typically, by the time you get from the Bs&W meter to the HMI screen, it can switch a little bit.
Okay.
You know what I mean? Because it'll sit
Because
there.
I
and
saw
bounce.
that be off. So I was wondering if once the HMI goes up, if that's when it cuts it.